All right. GM Rahat, I went ahead and started the YouTube live stream. So whenever you're ready to go, you can go ahead and share your screen, and Gloria and I will be moderating in the audience.
Awesome. Just setting this up properly. Okay.
Perfect. All right, I'm going to go ahead and tweet out the link, but we are recording and on live stream, and we're ready to go.
Awesome. Thank you all for tuning in. This is the third workshop for the Sparkling Hackathon. And for this one, we're going to be talking a little bit more about testing and security. So the primary focus here is really going to be on the testing side. We'll touch into security a little bit and why it's important. And I'll share some resources for you to dive deeper on the security side of things as well. So yeah, I'm back. This is Rahat. Again, if you ever have questions, want to reach out on anything that you're working on, whether it's in this hackathon or outside of it, I'm always DM away. So a little bit of what we're doing today. First, just kind of like discussing the importance of testing, why we do it, and going into then doing a live coding test. We're going to actually be doing a test for smart contracts that we wrote in yesterday's workshop. So we'll go through just like how you would approach writing some tests in Foundry and a couple of advanced like testing tips there. Um, the workshop is not, of course, going to be fully encompassing of like every single type of test that you can do on your contracts. There'll always be like different types of considerations you'll want to make. So we'll leave a couple of those considerations for you to like kind of think on and try out on your own. We'll also kind of like talk about the current state of security in Web3 right now and provide some learning resources for you to dive deeper to that side of things. But testing itself, why exactly should we even care? The why of testing. First of all, it's like it's it's great for like detecting bugs early. I would say like there's I've done this myself. There's a lot of folks who are like, oh, just put it on testnet and test it out and see how things work. Why waste even like the testnet tokens? Nowadays you have to actually buy Sepulveda ETH sometimes. So um, it's like it'll help you catch a lot of issues before you even deploy, whether it's on like a test net or definitely before mainnet. It's for evaluating like the proper behavior of your contract, right? Aside from bugs, like is your is the intended result actually happening? Like, or are you doing something entirely different and you just never knew? It's also really, really good for documentation. A good set of tests can like enhance or sometimes even kind of like dictate the direction of like how to make your docs a little bit better. Um, I think docs in general is sometimes a problem in Web3. It's like a little bit overlooked, or maybe not a little bit. It's fairly overlooked. So a good suite of tests will always be very helpful in strengthening the overall developer experience for folks coming in wanting to use like if you have a protocol or a dev tool because like they can look at the tests and like determine like how to actually use your smart contract or integrate your tech via those tests as well if you're building on like the infra or smart contract or tooling side of things there. And overall, it's going to really help you like build confidence, not just for developers, but for stakeholders as well, because your tests are there to, prove that your contract has their intended function. So at many times you'll want, to assure stakeholders that whatever, you're building, is going to do what it intends to do. So let's write some tests. Um, Going to VS Code. Great. So so we'll just really quickly go over the smart contract from yesterday that we wrote, and then we'll start writing those tests out. So this is a basic Ether wallet smart contract. If you've ever gone through like Solidity by example, this is based on an example from there. Um, but really quickly, it's a wallet, kind of acts as like a Web3 Venmo, where it can receive funds, it can transfer funds out, you can withdraw funds out of it. It explicitly states who the owner of this contract is um, during the constructor phase, and we have a modifier here of is owner to protect the different functionalities that are in here so that only the owner can actually call some sensitive functions such as, withdrawing ETH, as well as transferring ETH. Getting the actual balance can be called by anyone. Cool. So this particular contract, we scaffolded it out yesterday using Foundry. So if you're using Foundry, you scaffold out your project, you'll automatically get a test folder. So that's this little folder here. And the great thing with Foundry is a lot if you use Hardhat and like other tools to build out, you usually have to do your tests in a different language. In the case of Hardhat, you would have to do your tests in JavaScript. And overall that's fine, but it's like really, I think, a plus to be able to do tests in Solidity. Just kind of like keep yourself in the same mindset of like, okay, I'm just writing more Solidity to test my code. So this is one of like the cooler things about Foundry, just being able to test your Solidity code using Solidity code, which is really cool. Um, all right, so I'm going to go ahead and create a test file. Give me one moment. Just pulling up my notes on the side. Okay, so whenever we create a test file in Foundry, it has to have like a certain naming pattern. So we'll call this etherwallet.t.sol, and that will signify that this is a test, a testing file. And I'm just going to copy up a couple of things. I did not copy anything over. Okay. All right. So that's just as I would, start with any smart contract. This is also a smart contract specifically for testing. We're going to import a couple things. First, it's going to be from Forge. We're going to import test.sol. We're going to inherit from this specific contract to help us do our tests. We're going to import as well the actual smart contract that we wrote. So we're primarily going to be writing tests for the Ether wallet smart contract. We did also write a factory contract, which helps us essentially, which basically helps us with deploying additional wallets for other folks. We're not going to focus on that test, but I'll definitely leave some considerations for you to take if you want to try out building your own test for that one. And just in case we need it, I'm also going to import Forge STD slash console. So this is a console log. This allows you to print logs onto your terminal. So if you come from a JavaScript background, this will probably be pretty familiar. Console.log is what we're importing here. Just in case we run into any issues during our test, we'll be able to debug a little bit using the console. Cool. So I'm writing a contract. It's going to be called Ether Wallet Test. It is a test, so it inherits from that test. This test file here, and this basically just has like all of the different helper functions that are going to be used for doing like assertions and checking equality, that type of thing. Cool. We're just going to declare this variable here. It's going to be a public wallet. This is the wallet that we'll use to actually like deploy and test. Whenever you start a test within Foundry, the first thing you have to do is like create a setup function. So we'll create the setup function. And the way I like to think of this is kind of setting up our environment, right? So we'll say wallet equals new Ether wallet. And when we deploy our Ether wallet in if we go back into the file, oh, I'm in the wrong thing. Okay, here we are. We go back into the file. We'll recall that in the constructor, it's expecting an address to be specified as the owner. So I'm just going to essentially create an address from the number one. What this does is basically it sets the owner to an address based on the number one. So it'll be like 0x0001 or whatever. So that's going to be the owner of our contract. So this is important. This address is the owner of our contract for all of our tests. So this is the setup function, creating the environment of what basically deploying the contract for each of our tests. So let's start first by testing that, this address is indeed the owner. Just a very basic one, just to get us started. So we'll call this will be a function. We'll call it test owner. Important thing to note, anytime you write a test, the function needs to start with the word test. If it doesn't, then it will not run as a test when you actually try it out. So function test owner, view public. And all we're going to do is use this assert EQ, which means assert equals. We're checking for equality here. And we'll say wallet.owner. And we're going to say that wallet.owner should be this address because we passed this address to the constructor of the Ether wallet. So let's start with that. So this would how you would assert equality. The assert EQ takes two variables, and it'll just check if these two variables are equal to each other. So let's save that. What's going on here? Oh, I spelled public wrong. Okay. Okay. The Q is lowercase. Okay. That should do it. I'm going to open up my terminal and quickly run this test. So to run the test, I would just do forge test. Cool. It's compiling. Compiler one ran one test. Wonderful. That single test that we've written so far has passed. Great. So we've tested the fact that whenever we deploy a smart contract and pass an address, that address is indeed going to be the owner of the smart contract wallet itself. Cool. Just basic, just to get started. Let's now start testing so this is a wallet, right? So this wallet should be able to receive funds. And hopefully as we're going on, you kind of see how to structure your tests a little bit. The way that I kind of approach testing is I look at my contract and I start just picking through what is a basic setup this. When a wallet is set up, it needs to have an owner, so let's test that owner. Now what's another functionality of the contract that I can test? Well, wallets all have to receive funds, right? So let's test that it can actually receive those funds. You just have to break down little by little each of the bits of functionality that your smart contract needs to have, and you're going to test specifically those different use cases. So let's do another one. We'll call it test send ETH. And this is just going to be a public function. And it's going to receive some ETH, right? So the first thing we want to do is essentially create or essentially have an address with some ETH that can be sent to our smart contract wallet, right? So we can do that using this deal function. So deal takes two arguments, first an address. So we'll actually just use the address one again. So that's, you can think of it, this is the EOA that was our externally owned account or address or whatever that was used as the owner. And we're just going to give it some ETH. We'll give this person 500 ETH. I wish it was that easy to make 500 ETH, but alas. So we're gonna give the address 500 ETH. Now, before we actually continue, I'm going to create a helper function. And that helper function is one we're going to use to actually like do the ETH transfer. So I'm going to come down here and write a function. Let's just call it send ETH. And you notice this one, I did not use the word test because this is not a test itself. It's just a function I'm going to call from my tests. So I'm not going to use the word test here. Because I didn't use the word test, when I run the test, Foundry will completely ignore it during the tests unless I call it from another function. So this is going to take an unset integer of amount. And basically, we want to send that amount to the address of our wallet. So we'll say address wallet dot call value is the amount, and that should be good. So this will handle sending funds to our account. We kind of talked about this yesterday, but there's a couple different ways to send ETH. This is the preferred method of transferring ETH in Solidity. So now we have this function here. Cool. So let's go ahead and call that function. I'm going to say send ETH, and we'll send 200 of our ETH, hard-earned ETH, to this wallet. So we have 500. We definitely have enough to send the 200. And what we're going to do is, let's say, I'm gonna put in two tests in here. We're going two assertions. First, we're going to assert that the balance of our original sender has gone down to 300 because 500 minus 200 is 300 to verify that it went from the right place. There's a reason I'm doing that, and you'll see in just a second. So that's going to be address one dot balance. And we're going to say that that is 300. Cool. I keep capitalizing where I should not capitalize. Okay. I'm just going to copy this over so I don't do that again. And the other assertion that we're going to make is that the wallet itself, so wallet dot get ether balance is 200. Cool. So let's run these two tests and see what happens. Cool. So we had a failure. Fail reason, assertion failed. 500 does not equal 300. So 500 does not equal 300. So that's this test right here. According to this, when I run this test, it looks like the balance of my address is not 300. It is still 500, even though I sent 200 ETH over to the wallet. Now, the reason this happens is because when you're in this context, whenever you're running the test, so send ETH to kind of like conceptualize this, message.sender is always going to be the address of this specific contract. So you can think about it as like this contract, the Ether wallet test, whatever its address is, that's the address that is being used to actually interact with any of the functions that we call, right? So, and generally, like whenever you deploy, it'll just have like some really large amount of ETH on it, which is why this send ETH 200 worked. Like we were able to send the 200 ETH. We didn't get an error until we got here, but it's not being sent from where we're expecting. We created this address. We want to check specifically from this address, is our funds traveling over to our wallet? So to actually trick or change the message.sender in this case, we do have a function that will help us do that. The lovely folks at Foundry have an interesting naming way of naming things. So this is called vm.prank. So I guess we're pranking the EVM. And we're going to use that address 1 again. So now what vm.prank allows us to do is say that, okay, for the next function that I execute, this specific address is the message.sender. This is who is sending the funds. So for this send ETH of 200, we're going to expect that address 1 up here, which got the 500 ETH, is going to send this 200 ETH over. So now let's save that, rerun the test, and we have everything passing. So that's like a little tricky thing that you kind of have to remember. You're in this environment, you're testing from the smart contract. That's who message.sender is. And what you actually want to do, and we may not have had to do this specifically for this test. We were sending ETH does work, but I think it's always better to make sure you're verifying from like an address or some type of like external address. So that's why we decided to go ahead and do that. Cool. So now we know that our wallet can receive ETH. Wonderful. That covers another bit of functionality of our wallet. Another bit of functionality here is the ability to withdraw ETH. So let's test that out. Make sure that we can actually withdraw any ETH that is stuck in the contract and that we might want to take away from the dApp. So we'll call it test withdraw ETH. This will be another public function. And we're going to do similar stuff here. I'm going to copy this deal over. So we're going to start with this address with having 500 ETH. And now I'm actually going to do something slightly different than what I did here. So while here I did vm.prank, now I'm going to do vm.startprank. And it'll still have that address 1. So what is the difference between prank and start prank? So prank will only change the message.sender of the following execution line. Start prank will actually wait until you call stop prank to do the change in the message.sender. And I'll explain why we're doing it this way for this test in a second. But let's do our send ETH 200. Or actually, let's do it this way, and then we'll change it so you can see why this doesn't work for this test. So we'll switch over in a second. but we'll do the VM.prank first. And then we'll call wallet.withdraw ether, and we'll withdraw just 100, let's say. And then we'll make an assertion that address 1 should now have a balance of 400. Because we initially send 500, or we start with 500 ETH, we sent the 200, withdraw 100, we should have 400 within the address after withdrawing. So let's see what happens here. When I run this test, I'm actually going to do forge test, and I'm going to add a couple of V's here. I think I just probably need 2 V's, but the V just means verbose, meaning it'll give you like more information about the test. I believe 2 V's should be enough. Okay, cool. Let's actually add another V. All right, awesome. So now we get a little bit more information about like the actual execution of the test. So we got this fail reason, which is revert, caller is not an owner, right? So it did the initial deal, great. This address has 500 ETH. It did a prank, and then we were able to send the ETH. So the Ether wallet did receive that 200 ETH, but then this reverted when we tried to do the withdraw Ether, and the revert is because the caller is not the owner. Because, like I mentioned, the VM.prank, it only works for the following line of execution. But what happens here is that the wallet.withdraw Ether is being called from the Ether wallet test and not from this address. And if we look back at the function, the withdraw Ether function has the is owner modifier, so only the owner can call it. So we've inadvertently tested and successfully proved that only the owner is able to withdraw, which is great. Well, we should probably also write a separate test for that, but that's why this is failing. So, but that's not exactly what we're testing for here. So we'll remove the VM.prank and add in the start and stop prank. So now this wallet.withdraw ether will be called from address 1 rather than the actual contract address itself. So that should fix the test. We'll just do a regular forge test. Great. We got 3 passing tests now. Cool. So at times you might want to specifically test for a failure, right? So one of the failures that we just saw was that a non-owner should not be able to withdraw ETH, right? So we're gonna write a test that expects to fail. So if we're expecting a test to fail, you're going to name it test fail, and then whatever you want to name it. So not owner withdrawal. And what'll happen is that when Foundry runs this test, it is expecting it to fail. So if it fails, it'll pass. If it passes, it'll fail. So it just kind of reverts that. So this one, we actually want to make sure this fails. Cool. And we'll do some basically the same stuff here. I'll just copy and paste this because it's really the same, almost the same test. But really quickly, again, we're setting this address up to have 500 ETH. We set up the VM.prank instead of the start prank. We do the send ETH, we do a withdrawal, and it's the same assertion, but without the start and stop. But this time we named it test fail. So this should pass because it fails, it'll pass. It's a little weird to kind of like think of it that way, but that's what it is. So forge test. Cool. 4 passed. Because again, we named this test fail. So if it fails, that's good. We're expecting this behavior to fail. We don't want someone who is not the owner to be able to withdraw funds. Cool. Now, these are just like some basic tests that you can do. We'll go into like one type of advanced sort of like testing, and this is something called fuzz testing. So if you look at your contracts, the thing is like, even if we like go through all of these different examples, we're hard coding a couple of values to actually use. We're hard coding this value of 500. We're saying that, this address with 500 ETH is going to send exactly 200 ETH to the wallet, and we expect everything to work. Great. It works for 200 ETH. But how do you know it works for like several other types of inputs? How do you know that it's going to consistently work? Um, to test that, you would have to write a whole bunch of manual tests, right? With a bunch of different values. And doing that over and over is going to take forever. You can't I would personally never wish that fate upon anyone to like have to write a test like that manually of doing like hundreds and thousands of like inputs to assure someone that this always works. So we're going to write what's called a fuzz test, which essentially we pass like different variables to the function and say that, okay, these are different amounts. Basically, based on the inputs, Foundry will automatically just run through like a whole bunch of examples of testing with different inputs. So let's see what that looks like. So this is going to be a function. We'll call it test withdraw fuzz. You don't need to call it fuzz. You just name it test. The way that Foundry knows this is going to be a fuzz test is if you pass arguments into the function. So there's going to be 3 arguments that we pass. You got 256 starting balance. So every time we set up a test, we gave a starting balance to our address, right? So that is going to be this starting balance here. Next, we always send some amount of ETH to the wallet. So that's going to be this next one. So we'll just say that is amount. And then finally, we withdraw some other amount, right? So let's withdraw. Okay. So we've got our 3 functions. I think I just need to add public and spell this correctly. Okay. Yeah. Cool. So what's going to happen is whenever Foundry runs this test, it's going to use a whole bunch of different inputs for each of these arguments. And that's based on the type that it is. So because this is an unsigned integer, a regular one, 256, it's going to actually run this 2 to the 256 times. So all the numbers from there on, it's going to try each and every single one of those inputs as the starting balance. And it'll do the same for amount, and it'll do the same for withdrawal. So I think that should assure people that if we're running this test that many times, that this will work. For the sake of time in this workshop, we're going to drop this down to 16. Because I don't think anyone wants to sit here and wait for that many tests to run. Cool. If we do an unsigned integer 16, that's 2 to the 16. I think that's 256 or something like that. 256 tests. That's for this workshop, that's good enough. Cool. So we'll do similar stuff to what we've already been doing. except we're just instead of hard coding things, we're using these values. So the deal one address gets that starting balance. We do a vm.start prank. As once we start the prank, we can do a send ETH. Once we send ETH, I think I'm missing. Yeah. Okay. Once we send the ETH, we'll then test a withdrawal. So here we're just testing that you can always receive ETH no matter what the value, and whatever that amount gets sent, you can then withdraw, right? So we're going to use this assertion. We're going to say that the current balance is the starting balance minus the amount that was sent plus the withdrawal amount. So that should be the current balance of our address. And the assertion should just be that the balance of this address is whatever the current balance is. So let's run this and see what happens. Okay. All right. So it failed. Let's actually make it more verbose so we can see why it failed. All right. Cool. So if we go through, okay, so this is the fuzz test. All right. So it says fail to send either on this example. Let's take a look at what happened. So the Ether wallet was set up. We have our new Ether wallet. We did it looks like the fuzz test failed at 0. When it entered 0 as the input, everything failed because if we're just setting the amount here to 0 funds, there's no there's no funds to actually test this out with. So we want to make sure that certain numbers are not used because the you're never going to actually send 0 funds to anybody. You're just not going to do anything in that case. So sometimes real life doesn't match up with the way the test works. So to make this a little bit closer to like a real life situation, we're going to have Foundry assume a couple of things. So I'm just going to copy these two things over. Before we run everything, we're going to make 2 assumptions. vm.assume, we're going to assume that this amount is less than the starting balance. So this whatever our starting balance is, the amount that we send to the withdrawal to the wallet should be less. It can be equal to it as well. I'm just doing less just to keep it simple. Withdrawal amount should be less than the amount because the amount that you send to the wallet should not like you're not going to be able to send more ETH than that, right? So those are the 2 assumptions that we're making. So now if we test, that should work. Cool. Yeah. So you'll see here this passed. It ran 256 times. That's because we specified that these are unsigned integer 16s rather than the unsigned integer 256. So this ran 256 times with random inputs throughout, and it passed every single one of those times. So this is like an example. The wallet was given this amount of money. It transferred 298. It withdrew, and everything functioned as expected. Fuzz tests. So in this case, the Ether wallet is a pretty basic smart contract. So a fuzz test in this case might be a little bit overkill, But as you kind of like build more complex smart contracts, fuzz tests are going to be very, very important to like help you figure out like what are some edge cases, what are some weird things that happen on specific values, right? You might not always be able to like figure out what those values are. So what the point of these fuzz tests is, the point of like running this 256 or more times is to find out, like, see if you can find what those like edge case values might be so you can adjust your contract for them. Cool. So that is the end of our live coding section. So let's go back to our slides real quick. So we went through, we wrote a few tests. I'm actually going to be re-recording yesterday's workshop, so you all have that. Once that is re-recorded, I'll provide the code for that as well as this tests all in one kind of like repo. So you all can like go through and take a look at them. But some further considerations that you can take here, like diving deeper into fuzz testing, you can do something called invariant testing. And this basically is a test that a specific condition is always going to be true over the course of a fuzzing campaign. So as you're running these fuzz tests and with all these like different random values, there should be this is testing that a specific condition is always true. So let's say you had an ERC20 token, right? Maybe one thing you can test with the ERC20 token is that the sum of all of the user balances should always equal the total supply of an ERC20 token. If that's not true, there's something going on in that contract. So something like that, something you're just asserting that are specifying a condition that should never like be false, never not be true, and making sure that your fuzz tests are going through and making sure of that. That's called an invariant test. There's other types of tests in there as well. Definitely check out like the Foundry book. So the Foundry book is basically like the Foundry's documentation. So if you head over to Foundry book, this is really great for diving in. If you go to like their testing section, advanced testing, it'll go through a little bit of like the fuzz testing and variant testing. They have another thing called differential testing, which we won't go through during this, but it's really, really a great resource. This is, I think, um, one of the better docs in Web3. So it really takes you through like how to do some of these tests. So I recommend going through this as you're writing tests as well. It starts off with like basic writing, little cheat codes of like what you need to do. Um, and yeah, so great resource there. Additionally, like if you want to get more practice, I would recommend maybe like adding tests for the factory contract itself. And if you recall, the factory contract actually has events for like whenever a wallet is actually deployed. So you can actually test specifically for events, test that an event was emitted. You can even test specifically for different error messages. So we had a few error messages in our contract, depending on certain situations. In the test fail, I just like did like an assertion for it to fail, but you can actually test that specific error messages are being sent to a front end or to someone listening whenever there's a specific failure. And then doing things like adding, if you are doing the challenge from yesterday and you add the additional features to the wallet, such as like an ERC20 transfer, take a look at just like how that changes your new tests, right? Um, we talked a little bit about like the total supply of ERC20 tokens here, but there's different considerations to make. Maybe you have to test things around like approvals and transfers of like the ERC20 tokens. That might be a little bit different than just doing, regular e transfers. Cool. So we talked about testing. I think that's like a fundamental part of like what goes into the broader kind of spectrum here, which is security. So I've got this graph here. So credit for this graph goes to Cypher and Audits. Took this from their Twitter. They or X or they posted this some time back. But this is a graph that shows the cumulative amount lost in millions of dollars um, of audited contracts versus unaudited contracts. So you'll see unaudited contracts, which is the little orange line, have lost a significantly higher amount of money than audited ones. Audited ones generally, you'll be able to catch specific issues, maybe not every single issue, because there are still um, things that happen there, but you're able to statistically show that an audited contract will have less issues than an audited one. And when you're dealing in DeFi, when you're dealing with like millions of dollars for folks, getting your smart contracts audited is an important thing. It's an important step to do before going and launching something on mainnet. Um, so definitely for folks who are in this hackathon, if your plan is like go into mainnet, this is something that you do have absolutely must consider before going there. Um, and again, these are like our developer resources for building out and trying things here. One thing I just quickly forgot to mention, if you're looking into diving further into like the security side of things and how to write like more secure code, we'll be working on like a couple future workshops for basic security principles. We're not auditors ourselves, so while it may not be as comprehensive as something that Cypher would have, we'll hopefully be able to give you some starter points to go from. But Cypher actually has like courses where you can dive in, learn Solidity, and even learn like a lot of like the fundamentals of smart contract security. So definitely recommend them as a resource if you want to dive more into the security side. But you can also do different things like Cypher is free. There's also free resources like Ethernauts, which actually like takes you through hacking smart contracts so smart contracts. So like you understand the types of exploits and things that happen in the way you write the code. Cool. So yeah, this is again our developer resources for getting up and running. All of the code will be available here once at a later point this weekend. But cool. Thank you all for joining in. And if there are any questions on YouTube or anywhere, happy to take those.
Hey, Rahat, it's Goya here. I just wanted to reiterate that thank you so much for going through this deep dive. I found it to be really informative. Hopefully everyone else did as well. If you do have questions, throw them in the chat real quick on YouTube, and we will go ahead and get those questions. And if you're or get those questions answered. But if you're watching this post this current time and you still want to have your questions answered, you can go ahead and throw it in our Discord as well, and we'll make sure that the team answers it too. And I don't see really any in the chat currently.
Cool.
Yeah. I don't see any in the chat, Rahat, but I always love learning from you. So this today was just like another reminder about how much I love it. But thank you
Yeah.
for so much for going in deep with it. And hopefully people learned something. I know there's a couple of people who this is their first time going over testing. So kudos to that. And yeah, if you have questions on this, give it a try over the weekend and attend the office hours. Or if you want to, you can also just drop it in Discord.
Awesome. Thank you so much,
Well,
Rahat. And yes, we'll see you all on Tuesday, 9 a.m. Pacific for office hours in the Morph Discord. And for those of you who are listening in the future, which we tend to get a lot of those too, if you are interested, be sure to check out the Spark Loom Hackathon with Morph. You can find that on Biddlebox. It is linked to this video as well. So good luck, everyone. And we're
Oh, and Lisa, sorry, just one more reminder too. Tomorrow we're going to be having a chat on Twitter, a Twitter Spaces about builder incentives. So kudos to you all. Like join us tomorrow and we can talk about building and some of the incentives for the people who are participating in the hackathon and what happens next.
Oh, that is going to be very exciting. I will be sure to I'm going to add that to the workshop calendar on the hackathon to make sure all the builders can make it.
Cool. I'll get you
Yay.
the link.
Sweet. All right. Thanks, everyone. I'm going to go ahead and stop the live.